This is the second week of dynamic programming. We will look at how to solve two of the problem in the problem set. All right, so the first one we look at is what goes up. Okay, so you should go ahead and read the task statement first, and then we'll come back and talk about it. Okay, so maybe you pause the video for a minute and then go read the task statement. Okay. So this problem is generally referred to as the longest increasing subsequence. Okay, so the idea is like you have a sequence of numbers. Say, let's look at the example from the task. This sequence of numbers. Okay, this sequence of numbers. And if you pick a subsequence is a sequence inside this that can be obtained by deleting some of the number. Say this one. This is a subsequence of length 4, but it's not increasing subsequence. Okay, but this one is, so let's say if I remove this and I get -7, 2, 3, 8. This one is increasing subsequence. This one is not, because this is not increasing, right? So this one is probably the longest non-decreasing. But what we want is the increasing, right? So you cannot have 8 here. So this is of length 4. Okay. So probably this is one is the longest, but the task statement asks you to output the one in the last one. So probably be this -7, 2, 3, and 6. Okay. Also of length 4, and it ends with the last number. Okay. Okay, so that come last. So this should be the output. So the output should be you can try to find some other subsequence. They're not increasing, or the length is less than 4. Okay, so this should be the output. Okay, so how are we gonna solve this? We're gonna use dynamic programming. Okay, DP. Okay, so as a quick review, to be able to use dynamic programming, you should be able to come up with the recurrence of the function that you would like to optimize. But before you can get the recurrence, you need to think about the sub-problem. So what are the problems that you would like to solve? And it should look the same when you try to make some choice and you reduce the problem into a sub-problem of the same kind. Okay, and then that's how you get to the DP, right? So if you think about this, let's think about it for a moment. Okay, so you have a few numbers. So let's say you have numbers A1, A0, A1. Let's say A1. Okay, so it would be 0. Let's start with A0. Should be fine. A2, and so on. Okay. And if you get AI plus 1, so on, AN. Okay. So let's first think about the choices that you have. Okay. So let's focus with some guy in the sequence. Okay. So what choice do you have for this guy when you are looking for the solution for longest increasing subsequence? Okay. So the choice that you have, so you want to find a subsequence, right? So an obvious choice that you can make, obvious decision that you can make when you look at AI. So when we look at AI, we can sort of like just ignore the rest for a while. Ignore this for a while. So let's look at AI. What are the decision that you can make at AI, right? So you can either include AI in the sequence, or you can just ignore AI. So if we ignore AI, I just don't care about it. But if I include AI, okay, if I decide that okay, I'm gonna include AI, so what's the best way to come up with a solution that includes AI? Okay, so if I ignore the rest of the sequence, think about this. So if I ignore the rest of the sequence, AI would be the last guy in my subsequence, right? but I need to make sure that my subsequence is increasing. Okay, so if I gonna include AI, it has to come after some guy in the sequence, right? So if AI is say 10, can it come after 20? No, right? Cannot come after 20. But if there are something like 5, 7, 6, like this, it can come after 5, right? 5, 10, 7, 10, 6, 10, right? So these are the possible numbers that comes before AI. Okay, so I need to look at the numbers that are less than me. Okay, so that I can add I can put AI after that numbers. Okay, to be concrete, when I look at 3 here, 3 can come after 7 and 2, right? So that are my there are that's after I decided I would include 3 in the sequence. 3 will be the last guy in my subsequence. The guy that comes before 3 can be -7 and minus and 2, right? But which one would you like? Would I wanna go after? Like, which one should be the one that I would be directly after in the subsequence? If you think about this, I should pick the one that gives me the longest subsequence ending with 3, right? So these are the possible choice. Okay, so I should put AI after some AJ, where J is less than I and AJ has to be less than AI as well, right? Such that the length of the subsequence is longest. Okay, now how can I know, like, if you want to put it after 6 or if put it after 7, how can I know the length of the longest sequence after that I put AI after that those numbers? Okay, you can see that. Okay, so this is roughly the same problem that I would like to solve with AI, right? When I'm at AI, I would like to find the length, like the longest subsequence ending at AI, which are increasing, right? So to be able to solve the problem at AI, I need to, if I know the answer of the problem at every other position before AI, I can use those answer to guide my choice. Okay, so this the length of the subsequence, the longest length of the subsequence, okay, and also increasing, that would give hint to the subproblem that I'm looking at. So the subproblem that I'm looking at is this, right? So let me define this. Let This is AI already, so let's call it BI. LI be the length of the longest increasing subsequence ending at AI. Okay, so let's call this Li. So this is my subproblem. So now I can define the ending. Okay, so this is my subproblem. Now I can define the recurrence. So Li is gonna be, has to be max, right? Max AJ, max J. I need to find someone that comes before me. So max J such that J is less than I and AJ has to be less than AI, right? Of LJ. Okay, plus 1. Okay, you should think about this term a little bit. Okay, if there's nothing here, then this should be 0. Okay, if there's nothing in the index that I can be used. Okay, so this is like I'm picking the index j. Okay, I'm finding aj, mai, right? I'm finding aj that comes before me, that gives me the longest sequence ending at aj. And if aj is less than ai, I can append ai to the sequence, and I also get the increasing subsequence. So I'm picking the best choice. So that's why I need to put the max here. Okay, so this is my recurrence. Okay, given this recurrence, you can pretty much implement a program that find the maximum length. Okay, but to be able to come up with the solutions, you need to print out the solution as well. But this is like probably the really good starting place. Okay, so let's go ahead and write some code. Okay, so in this task, it's a little bit difficult to read the input quite a bit because there's no ending and starting, right? So yeah, so you should be careful about it. Okay, so I will keep okay, now I'll keep the input in this array vector a. Okay, so let's call it a. Okay, so while in, let's read it. That push back x. I also need to keep the number of guys there. Okay, and process. So that's the way I read the input, and then I need to read input. Okay, and then I need to find out the value, right? The solve the recurrence. So I also need to keep the solution. It's called L max n. That it doesn't say that the length of the input. I guess it should be 5,000, but let's say 100,000, 10,000. Okay. Okay. So now let's write the let's implement the recurrence. Okay. So if you look at the recurrence that we have, to be able to compute the li, you need to know every value of li, lj before I, right? So that's pretty obvious. To compute this in the loop, I would start with L0 and then I compute L1, 2, 3, and so on, right? So if you look at this, then that's not hard, right? If you know everyone before you, then you can compute Li pretty easily. So let's do this. So for I guess then n equals us, and then here I'm gonna find Li, right? Find Li. Okay. Now I need to find the best one here as my candidate, right? So I need to take the max value, and I also keep the index, right? So index. So the one before me, let's say is of length 0, and then for int j 0, j less than I, j plus. This is the something before me. So if aj is less than ai, if it's smaller, and also it gives me a better something better than mx, right? And lj larger than mx, then I would say mx equals lj. That's it. So my li would be mx plus 1, and then I need to output. But what is the longest sequence? It's not going to be ln minus 1 because it has to the longest sequence has to end somewhere, right? So it might not be the last guy, right, with the longest sequence. So I need to keep track of the my best solution as well. So let's call it this. So if li larger than base equals li, Let me just see out. Okay. All right. So that's the code. Let's see if it runs. Oh, haven't defined declare X. Okay, so let's try with this input. So let's try this. -7, 10, 9, 2, 3, 8, 8, 6. Okay. Okay, the length is 4. Okay, now you need to output the sequence. Okay, you need to output the sequence. How can you output the sequence? Okay, so you need to also remember the choices of the guy before you, right? So before that, I need to say parent, let's say -1, and I figure out the best guy. I need to pick the one with the largest index possible. So I would do this if larger than equal to mx. So I want to keep index j with p, right? So I say p equal to j here, but I need to pick someone with the the latest, because the question say if there are many sequence, you should print out the last one. So I pick the last guy here. Okay, and then I say bj equals p. So b keeps the index of the guys that come before me, and if this is better, last one, at least the best one, I keep the best, and I also keep base index. So it equals -1. So I also keep this base index equals I. So I need to keep track of the decision that I've made. Okay. Now, so then I need to output the new line, and I need to backtrack over this base index. So the last guy will be the one with the base index, and then I need to backtrack, but I need to print out from start to finish, right? But if I follow the base index and the b pointer here, I will get to the last one first. Okay, I print out in reverse. So you can either use a vector and put stuff in the vector and then print them out in reverse, or you can do that. So let me try to print the thing out in reverse first, and then you can fix the code yourself. Okay, so let's say let's try to print it out. So base index. Okay, and it would end when base index is -1, right? Because the first guy, the index of the first guy will be -1 because I keep it here. Nobody comes before me. So okay, so my loop will be y current. It's not -1. Then I just see out a current, and then current equals b current. Okay, that should print the thing, but in reverse. So let's try to compile it. Oh, bj bi, sorry. Okay, so it print the thing in reverse, but you can maybe fix this so that it print out correctly. Okay, so the whole thing is probably this, but the key thing for the recurrent is just pretty much this without the p. Okay, so you should be able to deal with that. All right, so the first task is roughly this. Okay. So a quick remark. So let me give a quick remark on the task that in the grader. So the one that we use solve is what goes up easy. Okay, so the one in the UVA 481 has a larger input. So the version that we implement run in O. Let's try to analyze it. It's run in n square, and it won't run in time. So you need to do something else to solve this recurrent faster. You need to do something else. So you want the solution that we have just implemented after we reverse the output won't pass the UVA problem set. So it's going to be optional. So the one that we look at in the task statement is this one. Okay. So the easy one. In that case, n is at most, I think, 2000. Okay. You can try to think about it. So in your test case, you can just let n be 2010. It should be okay. Okay. Now let's look at the second problem in the problem set. That's the longest common subsequence. This one. Okay. So you should go ahead and read it for a bit, and then I'll come back and talk about how to solve it. All right. Right. I hope you read the task statement of longest common subsequence. Okay. So the idea is like you have a sequence of alphabets. So it can be numbers as well, but in this task, you have a string, 2 strings. So let's see from the example. Let's say this one and this one. Okay. So the common subsequent is probably this A, D, H. That's probably the common subsequence. But there can be some other. Let's see another example. Let's look at this example. So the common subsequence is probably this A, B, C, D, E. This is of length 5. But if you take this T, H, I, J, K, this is of length 6, right? I forget the F here. So this is the longest common subsequence. Okay, but that it doesn't have to be consecutive, contiguous, right? It can be some space in between like that. Okay. All right. If you recall this from your algorithm class, in this case, we need to really think about the sub problems. Okay. So let's call this this string S and this string T. Okay. And also let's say SI be the prefix of length I. So S1 is, in this case, S1 is A, S5 is A, B, C, D, E, something like that. Okay. Okay. And also let's say SI, that's the ith character of S. Okay. Okay. So to come up with the recurrence, we will think about this as finding a matching sequence, like here A, B, and D match with this, H match with H, like that, or maybe L match with L, K match with K, like that. So you think of this as try to match of a character of S and T. So let's look at another example. Let's look at this one, H and H, D and D, stuff like that. Okay. Now, if we have S and T, the choice that we have to make, so let's say these are some alphabet here, some characters here, and some characters here. Okay. And we need to make some decision, right? If we don't have the starting point, our decision making will be really, really hard, right? So we probably need to think about the last guy, this one and this one, and we will make some decision about it. Okay. So if we want to make sure that we would like to match as many pairs of character as possible, and we want the match to be like this and that, and maybe that and that, right? But we don't want the match to look like if I match this guy and then I match this guy with this guy. That's not possible because they do not form common subsequence, right? Okay, so if I match this with that, say this is A and A, I cannot say I want to be this B and B to be matched, right? So the match, the way I match would correspond to the common subsequence between 2 strings. Okay. So the starting point for finding the maximum number of match would be the last character in the string, and then if they are the same, I can match it, or maybe I don't want to match it. I don't know, depends. But if they're not the same, say this is X and this is A, then I cannot match them for sure. But it might be the case that I would match A somewhere around here, right? That's the first choice that I made. Or maybe I match X with some guy here. If I match X with this guy, then A cannot be matched with anyone. And on the other hand, if I match A with this guy, then X cannot match with anyone. Okay. So so that's how I'm gonna do it. If they're not the same, if they're the same, I'll match it, or maybe I'm not, right? But the other two cases, like I'm gonna, when I want to match X with this, I will not make a decision that I will match X somewhere. I'll make a decision that I would ignore A. I would throw A away. Okay, and if I throw away A, the best subsequence I have is gonna be the best way that I deal with the sequence with this length, right? With the last guy deleted. Okay, so let's try to be a little bit more formalized about this. Okay, in this case, we can think of the string as the whole string, but it won't really help much, because we try to think about the thing in general terms. So I want to look at the prop. So I want to look at Si and Tj. So I have the prefix of length I here, and I have prefix of length j here, and then I'm gonna look at the ith guy and the jth guy here. So I'm gonna look at Si. So that this is the ith character, and Tj. Okay. If they're not the same, then I'm either kill this guy out, or I'll kill this guy out. Okay. Okay. And then I'm trying to find the maximum number of match. All right. So so this sort of like give me the roughly the subproblem. So given Si and Tj, find the length of the longest common subsequence of Si and Tj. Okay. So let's define it. Okay. So let's call it A. Then this will be my sub problem, and then I'll define the recurrent later on. Okay. It's called A. But here you can see that there are two indices here. So the harder DP has larger number of, the number of variables that you have is gonna be a little bit higher. So in this case we have two variables, so I and j. Okay, so this is the length of the longest common subsequence of Si and Tj. Okay, so now let's try to define the recurrence. This case, I'll start index with 1 when I implement this. We'll see soon. Okay, I'm gonna make there are choices that I have to make, but I want the longest, so this should be the max. Okay, what can I do? So I am either, so let's draw it like this. Si and Tj. I would focus on the last one. Okay, so if they're the same, I can just match them, and I get 1 point here for the match. So that's the common subsequence. Okay, and then if I make this choice, the longest common subsequence is the best one that I get when I try to solve this problem, right? So this is Si minus 1. So the last guy has already been matched. So what is left is Si minus 1, and what is left here is Tj minus 1. Okay, so I'm gonna get 1 point here, 1 plus. The best way to deal with, to match Si minus 1 and Tj minus 1. So it's gonna be Ai minus 1, Aj minus 1, if Si equals Tj. Okay. Otherwise, I need to do something else. I cannot match them. Okay. I can either throw away this. If I throw away this, the best way I can do is like I'm gonna match the whole thing here with the si minus 1. So I'm gonna get ai minus 1 j, or the other way around is like I queue this and I match the whole thing with this. So this is gonna be ai j minus 1. Okay, so that's my recurrence. Okay, but to implement this recurrence correctly, you need to think about the boundary condition as well. Okay, so I'm gonna start ai and aj with 1. The first alphabet will be 1. Okay, index will be 1. So my boundary condition will be a0j. If nothing left from the one guy, will be 0, and also ai0 will be 0. Okay, so that's my recurrence. To evaluate this, we can use a table that look like this. Okay, and we fill out the table like this. So this like index 0 up to the last one will be n and m. So s is of length n, and this is of length m, stuff like that. And here we put the boundary condition to be 0 like this. And when we try to evaluate this point, ij, you look at this position, I minus 1, j minus 1, and this position and that position. Okay, so to implement this, we can try to evaluate the table like this. So we go row by row, and then make sure that when we evaluate this, all the points here is already been evaluated, like the row before and the column before. Okay, all right, so that's how we're gonna implement it. If you get confused, try to go back to the lecture in algorithm class, or ask me in class. Okay, so now let's try to implement the thing. Okay, all right, so I need to read the input first. So I do the common pattern that we use. The input doesn't specify the number of test cases, but we can just read the input and see if the input is there or not. If it's not there. If cin return false, then that's it. Okay, now I need to find out the length of s and t. So I say n equals s dot length, n equals s dot t dot length. All right, so that's my input. So let's make sure that it actually works. Just read the input. So let me try this with the test case. Oh, okay. Okay, let's see. Okay, it reads the input. All right. Now I need the array for the my solution. So it's gonna be 2-dimensional array. Let's call it A. Max n and max n. That's the max length. Okay. Now I need to initialize the whole thing. Okay. So let's do this. For I less than or equal to n, I plus plus. So the first column, the first index will be n, the s n, the other will be m. So let's call it a I0 will be 0. That's the boundary condition that I'm talking about. And then m, so 0 I will be 0. Okay, now I need to implement my recurrence. Okay, so let's do this. I equals 0, I equals 1, n plus, and then j equals 1, j less than m. Note that I start the index with 1 because I want the boundary condition to be on the array. Okay, so that's this part, this 0 part here. In many cases, typically in C++, your array start with 0, right? But I'm intentionally start this with 1 so that my index will be fine. Okay. Now I need to evaluate find aij. Okay, so there are two cases, right? I need to look at the ith character of s and the jth character of t, right? So I need to get character from the string. Okay, so there's an operator here. So if si, but recall my I start in the index of the character in string start with 0, so I need to subtract 1 here so that everything should work. So if they are the same character, so let me say aij equals 0. So I initialize the whole thing with 0 first, and then if that's the case, then I would just so if you look at the recurrence, it is either this or that, right? And takes the maximum. So I'll try to I'll do this first. So let I say -1j. So that's the first case, right? So this case, okay. And then I'll see if a j I j -1, if this is larger than aij, right, then I update aij. So this is like implementing the recurrence. Okay, this two is to find the max, right? And finally, if the character is the same and if ai -1 j -1 like is larger than +1, right? So this is this term. Okay, so this is the largest, then I update aij to be this value ai -1 aj -1 +1 there. Okay, so that's exactly my code basically. Okay, and then I need to print out the so hold on, I need to read one input and then implement this. Okay, and find the best value, longest common subsequent, the length should be an m, and that's my code there. All right, so let's see if it actually runs. Okay, I think that's correct. All right, so this should give you the roughly the solution. Okay, that's how you implement it. So basically from here you need to be able to translate the recurrence back to C code, and this is like the max, implementing the max and if stuff like that. Okay, all right. I hope you can continue with the other problems in the problem set. If you have problem, if you have issues, questions, ask me or the TA. Okay. The other two require problem, maybe you might need to another way to read input. So I would provide templates as well. All right. Okay. Good luck. See you in class.